line 22, 7B241, Repulsive Capasso Experiment Data, Casimir Lifshitz Forces, DARPA, Wow Seti. There's the alien radio signal. And we're going to talk about Capasso vacuum, liquid, bromobenzene, metal plates, gold, polystyrene sphere, cantilever, silica plate, dielectric permittivity, quantum fluctuations, Repulsive Casimir Lifshitz Forces, keyword research in line 22, WOW data. So February 23rd, 2014. The previous video was line 22, 7B240, Repulsive Forces, Capasso's, Casimir Lifshitz, Quantum Levitation, DARPA, Wow Seti. So the keyword is Repulsive Casimir Lifshitz Forces, and the quote from the blog is, Capasso's team replaced the vacuum with a liquid, bromobenzene, and instead of metal plates, used a gold-coated polystyrene sphere attached to a cantilever and a silica plate. The key to the experiment is the dielectric permittivity of each of these materials. This property represents a material's ability to carry an electric field. To get a repulsive force out of the system, the dielectric permittivity of one plate must be higher than that of the surrounding liquid, and the dielectric permittivity of the second plate must be lower than that of the surrounding liquid. We're talking about a repulsion that is controlled by the ordering of the dielectric properties of the materials, not the shape, says Capasso. In the setup used by Capasso's group, gold has the highest dielectric permittivity, followed by bromobenzene, and followed by silica. The Casimir Lifshitz force works so that the liquid is attracted into the gap between the two, forcing them apart. Capasso used the cantilever attached to the gold-coated sphere to measure the size of the repulsive force. A change in the beam of light reflected off the top of the cantilever signaled movement in the system, and revealed that as the gold sphere was brought close to the silica plate, it got pushed back. The results are published in Nature. The effect occurs only at separations of less than about 120 nanometers. The researchers found the force to be strongest around 150 trillionths of a newton, when the gold and silica were about 20 nanometers apart. This paper is a milestone in experiments on Casimir forces and quantum fluctuations, says physicist Ho Bun Chan at the University of Florida in Gainesville, who works on micro-electromechanical systems. Steve Lamoureux of Yale University was one of the first to accurately measure the attractive Casimir Lifshitz force and is impressed by Capasso and colleagues' experiment. The Casimir Lifshitz force has become a bit of a nuisance for nanomachines, Lamoureux says, and harnessing the repulsive force may provide a solution, stopping tiny clean surfaces from sticking together. The next step is to use the phenomena to levitate a tiny piece of gold or other material in the liquid. The levitation experiment should be straightforward, says Capasso, and if so, could be exploited in tiny machines within 10 years. I have a hunch that something useful will come of this, he adds. And that's from www.nature.com. So the keyword to Google will be quantum fluctuations, and that data will continue in the next video. Thank you for watching.